All right. All right, so we're still talking about exponents today. So yesterday we talked about the product rule, and today we're going to talk about the quotient and power rules. So for the power rule, for exponents, so if you have something that's raised to an exponent and then that whole thing is raised to another exponent, you just simplify that by multiplying the exponents. So for example, if you had x squared and then that was raised to the third power, so that would be the same thing as x squared times x squared times x squared. And then using the product rule that we talked about yesterday, you just add up all those exponents. So 2 plus 2 plus 2 equals 6. So that's x to the power of 6. Or in other words, the shortcut is to just multiply the exponents. 2 times 3 is 6. All right. And then the quotient rule. So if you're dividing two exponential expressions that have the same base, then you just subtract. So b to the m over b to the n equals b to the m minus n. So you just subtract. So the fraction turns into a subtraction. Hello. Here you go. Here's the paper, the note paper. All right. So for example, if you had x to the 5th over x squared, you could write that out 1, 2, 3, 4, 5, 1, 2, and then you could cancel and cancel, and you'd be left with 3 of them. So the shortcut is to just subtract. 5 minus 2 equals 3. And then for negative exponents, so b to the power of negative n is the same thing as 1 over b to the power of positive n. So let's see. So for example, you could have, say, x cubed over x to the 5th. Okay, so if you use the quotient rule, you would say 3 minus 5, which would equal -2, and that would give you x to the power of -2. Okay, if you do that same problem by writing it out, 1, 2, 3, 1, 2, 3, 4, 5, and then cancel and cancel and cancel. So everything on the top canceled out, so that's a 1, and then on the bottom you have x squared. So 2 different ways of simplifying that expression. One gives you x to the power of -2, and one gives you 1 over x squared. So that shows that these 2 expressions are the same thing. All right, so I just want to show you, my point in doing all that is just to show you that these rules do make sense practically. They're not just random made up junk. This is what I think a lot of students think, that someone just made up all this random stuff. It's just meaningless. It's not. And on that same note, also, yesterday we did mention, we didn't really have, I don't know if we really had any examples, but we did mention the fact that, let me just look at that one, see if I have it right here. Yeah. At the beginning of yesterday's notes, we did mention the fact that anything raised to the power of 0 is equal to 1, right here. See, right there. And so once we understand the quotient rule and stuff, we can also understand why that is true, because For example, if you had like x to the fourth over x to the fourth, if you use the quotient rule and you subtract 4 minus 4 is equal to 0, that would be x to the power of 0. But we also know that x to the fourth divided by x to the fourth, that's just something divided by itself. So we know that that would equal 1. And so that kind of explains why anything raised to the power of 0 is equal to 1. Yeah. Well, now you know why. There you go. Yeah, I know. I feel the same way. When I learned all this stuff, it was just like, here's a rule, the end, you know, and I actually just eventually after like you know, teach this stuff, you kind of start to like make those connections. And I was like, oh, well, that's why that's true. No, I don't even think anyone ever explained that to me. I just eventually kind of like figured it out. And I'm like, well, some of my students might actually want to know this. Some of them don't give a crap. They're like, just tell me the rules. I don't care why it's true, but I think it helps to know why it's true sometimes. It's good to know. All right. Yep. Okay. All right. All right, so we'll look at some examples here. All right, so number 1, y to the power of 8 over y to the power of 3. So just subtract the exponents. 8 minus 3 is 5. So that's a y to the power of 5. Number 2, so we have 30 over 15. So let's go ahead and reduce that first. So 15 would go into 30 2 times. All right, and then so we're going to have a 2. Okay, and then we have, so the way I would probably look at this is we have the larger exponent, go away, you silly thing. We have the larger exponent of z in the denominator. So we're basically just going to subtract 6 minus 3 is 3, and that's going to be in the denominator. It's going to be z to the third on the denominator. You could also think of it as like, okay, 3 minus 6 is negative 3. So it would be like 2z to the negative 3. And so that's the same thing, but typically it's considered more appropriate for your final answer to not have any negative exponents in it. So your final answer should be 2 over z cubed. All right. Number 3, so 7 goes into 49 7 times. All right, and then 3 minus 2 is going to be 1. So that's just going to leave x in the numerator. And then for the y is the same thing as y to the power of 1. So 9 minus 1 would be 8. So that's going to be y to the power of 8. So everything on the denominator canceled out, so we don't need it anymore. So your final answer is just 7xy to the power of 8. All right, number 4. So 3 will go into 48 evenly, and I don't want to have that negative. I know my answer is ultimately going to be negative, but I don't want to have that negative sign in the denominator. So you can either put it in front of the numerator. Yeah, I think that's what I'll do. I'll just put the negative here. And then, so basically 48 divided by 3. So that would be 16. All right, and then c to the 8 over c to the 8, that's just going to cancel out. And then for the n, we just need to do 11 minus 6, which is 5. So that's n to the power of 5. And then b to the fourth cancels out with b to the fourth. So my final answer is negative 16 into the fifth power. All right, using the power rule, so x to the power of 10, and then that whole thing is raised to the power of 7. So we just need to multiply the exponents. 10 times 7 is 70. So x to the power of 70. Number 2, so multiply the exponent. So negative 3 times negative 6 would equal positive 18. So the answer would be x to the power of positive 18. All right, number 3. So let me do what's inside the parentheses first. So basically, that's going to be x to the power of, so you could say 7 minus negative 4. And that's still raised to the power of 3. So minus a negative turns that into a plus, and so 7 plus 4 is 11. So you have x to the power of 11 inside the parentheses, and then all of that is raised to the power of 3, and then just use the power rule and go ahead and multiply 11 times 3, which equals 33. So x to the power of 33 is the final answer. All right, let's see here. All right, so number 4. So again, let me focus on what's inside the parentheses first. So, your goal is usually to get rid, well, I don't know. I mean, you can do it in different ways. Maybe I don't need to do what's in the parentheses. I mean, it doesn't really matter if I do which I do first, honestly. So, I don't know. It's 6 and 1/2 a dozen the other. Let's see. I've got that negative exponent on the outside of the parentheses. So if I go ahead and flip that fraction completely, just flip it, that'll get rid of that negative right there. So how about I'll do that first. So that would make it 5 over x cubed to the negative 3, and then y to the positive 7. And now it's raised all to the power of positive 3 instead of negative 3. Okay, so let's see. I can go ahead and distribute the exponent of 3 now. So basically take everything that's inside the parentheses and raise it to the power of 3. So 5 to the third power. And then on the denominator, negative 3 times positive 3 would equal negative 9. So it's x to the negative 9. And then 7 times 3 is 21. So it's y to the power of 21. All right. So 5 to the power of 3. So 5 times 5 is 25. Times 5 equals 125. And then x to the negative 9. So I want to get rid of that negative exponent, and since it's already on the denominator, I need to move it up into the numerator. And when I do that, that'll get rid of the negative. So it'll be x to the positive 9 in the numerator. And then that's still over y to the power of 21. So my final answer is 125 x to the 9 all over y to the power of 21. All right. Number 5, hey, a whole bunch of stuff raised to the power of 0, that equals 1. All right, on number 6, in this case, I definitely have a lot of stuff inside the parentheses that I can reduce, so I'm going to do that first. All right, so negative 20 divided by 4 would equal negative 5. And then with the a's, I've got the larger exponent on the denominator, so 10 minus 3 would be 7, but that's going to go in the denominator, a to the 7. And then for the b, 6 minus negative 2 is the same thing as 6 plus 2. So that's going to be b to the power of 8. That's in the numerator. All right, and then all of that is still raised to the power of 3. All right, so negative 5 raised to the power of 3. 3 is an odd exponent, so that answer is still going to be negative. So that's going to be negative 125. And then 8 times 3 is 24, so that's b to the power of 24 over 7 times 3 is 21, so that's a to the power of 21. All right. Number 7. Okay, so I guess I'll go ahead and start by distributing the power of 5 in that first set of parentheses. So 2 to the 5th power, x to the 5th power, and then 2 times 5 is 10, so that's over y to the 10th power. Okay. Now on my second set of parentheses, all of that is just raised to a power of negative 1. So basically, I'm just going to flip that whole fraction, which would get rid of which would make it to a positive 1, which means nothing basically. So it would end up being y to the power of negative 8 over 3x to the 8. All right, and so now we got rid of that negative 1, so now it's just a positive 1. So now we don't need to worry about that because something raised to the power of 1 doesn't do anything. Okay, let's see here. So I'm going to have, 2 to the 5th power is going to be equal to, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it's going to be 32. Okay. And then I guess I can just go ahead and say x to the 5th, y to the negative 8, all over 3x to the 8, y to the 10. And then, but I still need to simplify that. So the 32 and the 3 can't be reduced, so that's just going to stay the same. For the x's, I've got the larger exponent on the denominator. So 8 minus 5 is 3. That's going to give me x to the 3rd on the denominator. And then, let's see. So this one with the negative, basically you move that down there to make it a positive 8. And then it would be 10 plus 8 is 18. So that's going to be y to the 18 on the bottom. And that's the final. All right, number 8. Let's see. Okay, we have to, all right. So we've got a negative exponent. We need to deal with that. So what we could do is we can take this whole thing here and change that to 1 over 10. And so everything in the parentheses is going to stay exactly the same. 10x squared y to the negative 2. And then now it's raised to the power of positive 2 instead of negative 2. I'm just going to bring down the second set of parentheses. That's going to stay the same for the moment. All right. All right, I'm going to go ahead and distribute the power of 2 here. So I've got 1 over 10 squared is 100. And then for the x, 2 times 2 is 4, so that's x to the 4th. And then for the y, that's going to be y to the negative 4. So I guess I could just go ahead and like write it this way. 1 multiplied by that stuff in the parentheses is just that stuff. All right, so I've got 5x to the negative 7, y to the negative 2 over 100x to the 4th, y to the negative 4. All right, so I know that 5 could go into 100 20 times. And then for the x's, so that x with the negative 7 needs to move down, and that would end up being like 4 plus 7 on the denominator. So that would be x to the 11, and it's on the denominator. And then for the y, that's going to end up as a y to the positive 2 on the top. So if you think about, if you move y to the negative 4 up here, then it's negative 2 plus 4, which is positive 2. So my final answer is y squared over 20x to the 11. Alrighty. Any questions about anything? So we just have 2 more lessons, and then we're going to have a 3rd test, and then we're going to have the final. We could have the final early and then go ahead and start on 1332, possibly. I don't know. We'll see. So, but yeah, make sure y'all are doing all the homework. Should be nearing the end of that list of homework assignments. All right, I'll see you tomorrow. Braden, do you want to go ahead and just take your test now or take a break? Yeah, we can just stay it here, I think. Okay. Yeah, I don't know if there is like a class in here at 2. I mean, if there is, we'll just move out of the way, I guess, if you're still taking a test or whatever. I don't know. And we can always take like a 30-minute break if you want and then do it over at my office.